So welcome back to you all in Math Magic channel. Today in this video you will learn the basics introduction of number system. Okay, so let's start. If see introduction is given, numbers are the symbols 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 in Hindu Arabic system. These are also called digits. So we have basically in standard 5 and 6 learn about two types of number system. One is Hindu Arabic number system and another is Roman numeral system. In Roman numeral system you have seen they also have different types of digits, uh, symbols. To represent 1 they use I, to represent 5 they represent V, they use V, to represent 5, to represent 10 they use X, to represent 50 they use L. Then you will get C for 100, then you will get D for 500 and M for 1000. Right, using these 2, 4, 5, 7 symbols we can represent any number, we can write any number using this 7 Roman numeral system. In higher classes you'll also learn that if we put one bar over a symbol then it will be multiplied by 1000. So if we write one bar then it will be 1000, right? Similarly if we write m bar then it will be 1000 into 1000. So this things is also there. So in this way we can also represent the millions and billions, any types of trillion, any such a large number. Okay, fine. So this is all about Roman numeral system, all about Roman numeral system. If we talk about our Hindu Arabic number system, in that case you will get that we don't have this LCDM type of things. We have some digits and these are 0 to 9, 10 digits we have in our Hindu Arabic system. That is why sometimes it is called that base 10, convert into base 10. So you don't be confused if it is given in binary system 11011, so you convert into base 10. So base 10 means what? Base 10 means actually in our Hindu Arabic number system 10 digits are there, that is why it is called base 10, right? Fine. So we have 10 digit to represent any type of large or small number. Okay, proceed to the next part. So types of number we see that natural numbers mean the counting numbers start from 1 2 3 4 to infinite plus infinite. Okay, fine. And then you will get, if we introduce 0 then it will be set of whole numbers. And in the last video we told that natural number is denoted by n. Okay, in this way this is set of all natural number 1 2 3 comma dot 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 infinite. Okay, and a whole number 0 will be included. Whole number is denoted by W, and then second bracket you will keep all these things. Okay, and then you will get integers, and but the whole number is also uh, divided into three parts, that is whole number and natural number also divided into three parts, and these are, you will see that even numbers, odd number, prime number, these are another types of numbers or digits which comes from natural or whole numbers. So even numbers means the number which is divisible by 2, multiple of 2, all the numbers which are multiple of 2. Then a number which will be divisible by 2 is called the even number. It can be expressed as a pair of 2. Okay, so or multiple of 2, this is even number. Which will be odd number? Odd number means the number which is not divisible by 2. These are the general definition of even and odd number. Okay, here what definition is given? All counting number which are divisible by 2, all counting number which are not divisible by 2, these are called counting sorry, even or odd number. These are called even or odd number. Now coming to this prime number. Prime numbers are what? Prime number means a counting number. So these all are the types of counting number, you can say the counting or the natural numbers. These all are the subpart, you can say, of natural number. Even odd, prime, co-prime, one by one we will learn the basic concept of number system today. So prime number means a counting number is called prime number if it has only two factors. Only two factors. Definition is very nice, that it has two factors, and the factor is 1 and the number itself. 1 and the number itself. It is 1 and the number itself. Okay, 1 and the number itself, call the prime numbers. For example, 2, if we take 2, it has how many factor? 1 and 2. If you take 3, how many factor? 1 and 3. If you take 4, then how many factor? 1 comma 2 comma 4. So it has three factors, so it is more than two factors, 1 and the number itself. Okay, so since it has three factors, so it will not be a prime number. So only 2 and 3 are the prime number here out of these three numbers. Okay, so a number which will be divisible 1 and the number itself is known as which? It's known as prime number. Okay, now coming to composite number. Composite numbers are what? Composite number means a number which has more than two factors. More than two factors, these are known as composite numbers. So what definition is given here? Let us see this. So composite number, a natural number which is not a prime number is called composite. That means it will have more than two factors other than one and the number itself. For example, 4 I told, 6, 8, any numbers which has more than two factors, one and the number itself. Okay, known as composite numbers. Okay, fine. Then after, so first natural, then whole. Natural number has different types. So even, odd, prime, composite, and after whole number we will get all the negative, positive, and the zero. Okay, basically all the negative integer is denoted by a z symbol, and z come from the German word zahlen, zahlen, zahlen. This is German word which means to count, which means to count, which means to count. Okay, so z is z represent all the integers. All the negative integers are known as z minus, and 0 is denoted by z0, and all the positive numbers denoted by z plus. Fine. Okay, so this is all about the which one? Integer. Okay, positive, negative, and the z0. Now coming to this fractional or the rational number. Rational number. Okay, rational number is what? A number, a number which is a quotient of two integer. What? Quotient of two integer. I write quotient of two integer, quotient, quotient of two integer, quotient of two integer. Okay, that is why rational number is denoted by cube. Rational number is denoted by cube, quotient of two integer, p upon q. So p and q are two integers, so their quotient is known as rational number. Okay, mind it, this q quotient of two integer, denominator q cannot be 0. Denominator, if denominator is 0, then the things will be undefined, it will be undefined. If denominator is 0, then the rational number or any fraction will be undefined. All right, so this will be undefined. So rational number is what? If anyone asks, you don't say that a number which can be expressed in the form of p by q. You don't say this. You will say rational number is the number which can be expressed as the quotient of two integer, quotient of two integers, quotient of two integers. Okay, this is called rational number. It can be explained, the p and q both are integer, q not equal to 0, then you will explain, but main definition will be quotient of two integers. Okay, so that is why rational number is denoted by the set q. Okay, fine. So in this way, q is equal to p upon q, such that p comma q belongs to, this symbol is called belongs to z, means integer comma q not equal to 0. You know, this is called a set. A set is what? Collection of some element, each one is called the element. Okay, a set is collection of some element, where, and set also, it may be it may be a finite set, it may be infinite. So you, in the comment box, you write down that rational number set of all set of rational number will be a finite set, I mean there will be finite element, or it will be infinite, it will be infinite. If it contain infinite element, so set of infinite, it is infinite set, and if it contain finite element, so finite set. So you all think and comment me that rational number is finite out of these all. Okay, natural number, whole number, integer, uh, rational number and real, all these sets, which is finite and which is infinite set. Okay, fine. Next is irrational number. Irrational number is what? Irrational number, a number which can't be expressed in the form of p by q, that means which will not be expressed as a quotient of two integer, is known as irrational number, is known as irrational number. All right, so this is known as irrational number. Okay, for example, root 2 root 2. So if you expand root 2 or root 3, you will see there will be decimal form. For example, root 2 4 1, then dot dot dot. You not a group of repeating digits, okay, or single repeating digits, so it will be an irrational number. Irrational number, later we will learn there are two form. In gist form I'm telling you, although it is a part of standard 9, rational number will be what? Rational number will be what? Two types. Either will be terminating decimal. Terminating means after decimal 0.123 decimal, after decimal point there will be fixed number of digits. And non-terminating, either terminating or non-terminating, non-terminating, okay, repeating, non-terminating but repeating. What is this non-terminating but repeating? Example I'm giving you. Non-terminating means the decimal number 1 2 3 will not be terminated. Digits after decimal will not be terminated, rather the digits will be what? Repeated. For example, you see this 1.2333, 3 is repeating. Okay, so we will write down this as 1.23, then again one decimal point on the digit 3. This decimal point is called recurring decimal. Recurring decimal. Okay, just like reoccurring, it is known as recurring decimal. Fine, recurring decimal. Okay, fine. So that means 3 is repeating. If I write down, 0.223, and this is also called vinculum bar, so this means 2 3 is repeating. So you can write down this as how? You can write down this as 0.22323 dot dot dot. Okay, that means 2 3 is repeating. Fine. So this is the things that either it will be recurring point or it will be under the bar. Fine. So a rational number will be either terminating form or non-terminating repeating form. Okay, but irrational numbers will be what? Irrational numbers will be non-terminating, non-repeating. Non-terminating means it will, digits will not be ended, will not be terminated. Okay, non-terminating, non-repeating, repeating means terminate, it will not be terminated and also not be repeated. So sir, you give me, if you ask me to give one example, so I will give you that. What is the example? See, series. If I write 0.2303 dot c. So here is 03, then 003 means 03 is not repeating. So next if you expand, then you will get 3 times 03. Okay, so it is just like a number series, nothing is repeating. Although dot means non-terminating, so it is dot non-terminating, and not a particular digit or group of digit repeating, that means non-repeating. So rational number will be non-terminating, non-repeating. Sorry, irrational number will be non-terminating, non-repeating, but the rational number will be terminating or non-terminating, repeating. Okay, agar it will be non-terminating, then it will be repeating, otherwise terminating. And in case of irrational number, it will be this non-term, both are non, in case of irrational, non-terminating, non-repeating. Okay, but in case of rational, one will be non, another will be not non. Okay, means repeating, non-terminating, repeating. Here both non irrational, non-terminating, non-repeating. Fine. Okay, I hope you have understood. If you feel that I'm explaining little bit rapidly, quickly, so you can decrease the speed or you can increase the speed according to your convenience. Okay, fine. I'm trying to maintain moderate level so that you uh, feel the, you can enjoy, you can feel the concept, the topic, right? Okay, now real number include all these things, include all, rational, irrational, all. Fine. If you include all these things, combining all rational, irrational, you will get the real number. So if you want draw, this is called Venn diagram. Okay, so total whole set is rational. Inside rational you will get uh, real number, whole set is real. Inside real you will get it what? You will get two types of number, one is rational, another is irrational. In the comment section you SMS me, you text me that which symbol we use for the irrational. If you don't know, then you tell me, I will tell you. This is irrational number, set of irrational. Okay, totally different, rational and irrational. Fine. And inside this rational number we will get again different sets. That is, we will get integer z, inside integer whole number. Okay, and inside whole number we will get natural number. Okay, whole w and then natural. Okay, so this is n natural, then you will get w, then you will get integer I, and this is whole is under this what? Rational. This is rational q. And another is what? Another is irrational part. This is irrational. Okay, and containing all these things you will get this real number. Okay, so this is the diagram, two parts, rational and irrational. Inside the rational, integer whole, and all these things, integer whole number and natural number. Okay, this is a diagram of Venn diagram, explanation of number system. Okay, so now we will learn again some different types of uh, number, but these are the common concept. Okay, chalo. So LCM and ACF. LCM means the highest common factor. Two numbers may have a common factor. For example, if I write down the 12, if I write down 12 and 14, okay, so it has factor 2, 6, it has two factor common, okay. So the common factors is different and the highest common factor is different. ACM means highest common factor. Okay, one more example, it is 12. If I change it, if I write down 12 and 24, then you will get it 2, okay, then 3, then 6 are common. Here also 2, 3, 6 factors are common. But what is the highest common factor? Highest common factor is 6. Okay, so this, then 6 is the HCF. So you have to write all the factors and out of them you have to find out which is the highest common factor. This is called the HCF. Sometimes it is also denoted by higher class as GCD. GCD means greatest common divisor. Same things, 2 is a divisor of 12, 3 is a divisor, 6 is a divisor. So you can also call it greatest common divisor. So 6 is the greatest common divisor. So it has two names, HCF or GCD. Okay. Now LCM. LCM means least common multiple. Least common multiple. Okay. So for example, 2 and 3, right? They have multiple. 2 ones are 2, 2 3, 2 2 are 4, 2 3 are 6, 2 4 are 8. Again 3 1 are 3, 3 2 are 6, 3 3 are 9. Now you see this, that here which is common, which is the common multiple, which is the common multiple? Here 6 is the common multiple. After 6 you will get 12 is will be common multiple. Okay, then multiple of 6 will be common. 6 to the 12 will be also common multiple, right? And then 18 will be also common multiple. But what is the least common multiple? What is the least common multiple? Least common multiple is 6. So here LCM of 2 and 3 will be what? 6. Okay, so there are different process to find out the what? LCM and ACM. The popular process is for LCM is prime factorization process. You can do the prime factorization. One example I'm showing you for 8 12 and 24. This example, this one I'm showing you 8 12 and 24. How to do this? 8 12 and 24. You have this process called a prime factorization. Some students do what? They start with the composite number, but you don't start with composite number. Mind it, this is prime factors, so always you have to start with prime number. All right, okay, so this is 2 2 ja, 4 2 3 ja, and 2 6 ja. Again 2 1 ja, 3 will be as it is, 2 3 ja. Again you start with 3 3 1 1 1. Okay, so product of all these is LCM 2 2 2. 4 4 2 is 8, 8 3 is 24. So 24 will be the LCM in this case, 24. All right, so this is called prime factorization because we are using the prime numbers. 2 is prime, 3 is prime, and factors. So that is why this process is called prime factorization process. I hope you understood. Okay, next, HCF you have to find out using the long division method. Otherwise, in this prime factorization, you can also find out only the common factors will be multiplied. Okay, next is fraction. Fraction. So what is fraction? Fraction is what? A number expressed in the form of a upon b, where a, b are integer, b not equal to 0. This is called the fractional number. Types of fraction, we say that fraction is what? A part of a whole. Means you have one pizza, right, with you. You like, how many of you like pizza? You will tell me. So this is a pizza. Okay, so you have divided into many parts. You have taken three parts out of them. You have taken three parts out of them. Okay, this part you have taken, this part you have taken, these three parts you have taken. So what fraction of pizza you have taken? Tell me. So total part is 3 6 7. So you have taken 3. So answer will be 3 upon 7. This part 3 upon 7. So 3 upon 7 there will be the fraction. Okay, fraction will be always positive, but in our calculation simplification you may get the negative fraction, but fraction is in general what? Positive. Okay, fine. So type of fraction, we're coming to this type of fraction, coming to this type of fraction. first one type of fraction, this is proper fraction. The upper part is called the numerator and the lower part is called the denominator. Proper fraction, proper fraction is what? Proper fraction is, proper fraction is when the numerator will be smaller and denominator will be greater. You know all these things, that is why I'm not taking too much time, but once I'm discussing with you all. So improper is when the denominator will be, so a will be greater than b. When the numerator will be greater than b, then it will be improper, right? Like fraction are what? A numbers of fraction having the same denominator called like fraction. 3 4 fraction we have 2 upon 3, 4 upon 3, 7 upon 3, all the denominator is same. So if the denominator is same, then we call it like fraction. Okay, unlike mean denominator will be different. Now coming to this compound fraction. What is compound fraction? Compound, it is a fraction of fraction, it is a fraction of fraction. This is called compound fraction. It is of related fraction. Compound and complex, two different things are there. Compound means 1 1 upon 4 of 5 upon 7 of 7 upon 9. Okay, so this is a compound form of this fraction of this of this fraction. This is compound of. Okay, and complex means one fraction upon another fraction. So numerator and denominator will be fraction here. You see this 2 upon 7 and 4 upon 7. 2 upon 7 is itself a fraction, and it will be over upon 4 by 3. Okay, so 2 by 3 upon 4 by 3. So this is complex fraction. Okay, all right. Now coming to this mixed fraction. Mixed fraction is what? If you convert improper fraction into a whole and fractional part, then it is called the mixed fraction. Okay, 3, this 3 is called the whole part and this is called fractional part. So that is why we say this 3 whole 1 by 4. Okay, similarly 2 whole 1 by 4. What is the process? If I write 7 by 3, then you have to divide 7 by 3. So 3 to just 6, this is 1, so this is 2 whole 1 by 3. Okay, so this is 2 whole 1 by 3. So this is known as mixed fraction, where whole part will be also there and the mix and the fractional part will be also there. That is why it is called mixed fraction. Whole and the fraction both will be there, mixed form. That is why it is called the mixed. So one will be whole, another will be proper. One things you tell me that if improper fraction means, not only I want to highlight improper fraction not only greater than a denominator, improper means also equal to denominator. Okay, so if I say 5, then 5 is not a proper fraction, 5 means improper fraction. Okay, so improper fraction may be what? uh, a greater equal to b. If it is 5 upon 5, that means a equal to b, then it is also improper. Some MCQ question you will get it 5 upon 5. So what type of fraction it is? So mind it, this is improper fraction. Okay, it is improper, not proper. So actual definition of improper is greater than or equal to the denominator. Okay, so if I say 1, this is also improper fraction, greater or equal. 5 by 5, 7 upon 7, 2 upon 2, all these are improper fraction. All right, I hope you understood. Okay, that's all. Now this is mixed fraction. Continued fraction, continued fraction means that is a continuous form. You can see the example. Okay, it contain an additional in the numerator or in denominator. This type of 1 plus 1 upon 1 plus 1 upon 2 plus 1 by 2, this type of one zigzag stair type of things is there. This is continued fraction. Okay, fine. Next thing is decimal fraction. Decimal and recurring, already we have discussed about the recurring, how to what is the recurring. So one is pure recurring, another is mixed recurring. In mixed recurring, some digit will not be repeated, some digit will be repeated. For example, 2 3 2 5. under what 2 5. So 2 is not repeating, 3 is not repeating, but 2 5 is repeating. That is why it is called mixed recurring decimal. And pure means after decimal all the digits will be repeating. Okay, this is called pure. And if you want to take the screenshot, you can also take the screenshot to note it down in your copy. Fine. And decimal means, you know this, that in this type the denominator will be 10. Okay, has power of 10. 5 10 square, that means 5 by 100, so it will be 0.05. So a fraction whose denominator will be 10 or exponential power of 10, this will be decimal. Okay, fine. So this is all about one decimal is there, that's called vulgar fraction is there, this is called vulgar fraction. Vulgar fraction means if the denominator is not in the form of 10. Okay, so if denominator is other than 10 or exponential form of 10, then it is called the vulgar fraction. Any fraction when the denominator will not be 10 or or power of 10, then it is called the vulgar fraction. So this is all about the basic concept of number. I hope you have enjoyed this. So here is some formulas, you can also note it down. Some of the in natural numbers, some of the in sum of first in odd numbers, sum of first in even numbers. Okay, sum of in square of in natural number, for example 1 square, 2 square, 3 square, three numbers there, so n is equal to 3. So if you put n is equal to 3, you will get the sum in this way. Fine. So these things you can take a screenshot of these things. Yes, so this is very good essential point, you can remember, you can note it down. Okay, thank you so much for watching. I hope all of you have enjoyed. Keep studying. Thank you.